Alright everyone, and welcome to my first video for physics, and this one's on ray diagrams for concave mirrors. And a couple of people have told me that this would help them if I made a video on how to do ray diagrams. I don't want to do all of them at once. I want to see if these are helpful, so I'm going to just start with concave mirrors, and if these videos help you, please share them with other people and tell me about them so that I can make them better and make more if you like them. So let's start off with an object sitting behind the center of curvature. And the center of curvature is interesting because it's 2 times the focal distance. And this is something that you can use to find the focal distance if you're ever given the center of curvature but not given the focal length. So it's rather useful to know that this center of curvature is 2 times as far away from the mirror as the focal point. Alright, so we have our object. And now the first ray that we draw travels parallel to the axis and then reflects through the focal point. And I apologize if all of my lines don't line up perfectly well. If you use a straight edge, they will, but I don't have a straight edge to do this with on my computer. Okay, so the second line that you draw goes through the focal point, and this time it reflects parallel to the axis. So it's kind of the reverse of this first line right here. Alright, so the third and final line goes from the object through the center of curvature, hits the mirror, goes straight back. And as you can see, there's kind of a place where they all overlap. If I had done this with a straight edge, they would have all met at a point, and that would have been where this part of the image was. However, I didn't do it with a straight edge, so it's not perfect. But we can still see that the image is formed right there. So what does this mean? We have this dot. What does it actually represent? So if you're an observer and you're sitting here looking at this image right here, this object, this is the object, this is the image, just to make that clear. You're looking at it. What does this image look like compared to the object? So first of all, this image is further away from you than the object is. This distance is shorter than this distance right here. So we know that it's going to be diminished in size. That's because if you're sitting here looking at this object and this image, which is the same height as this object, but it's just further away, it's going to look like it's smaller. You can just see because this distance is further than the observer than the object is. Okay, so we know it's diminished. And it's not right side up, it's upside down. And you can see that in this ray diagram because the original object is above this line and the image that's formed is below. And you can kind of imagine like if you have like, let's say a stick figure and we're tracing the object as the top of his head. This is the new top of his head, so he would be upside down. He'd be like this. Basically, it's just tracing a certain part of the object. So we know that this is inverted. And most of the images that you form on a concave mirror like this are going to be inverted, but there is a special case in which it's not. So stay tuned for that. And finally, this is a real image because it's formed in front of the mirror. It's not somewhere back here behind the mirror and the eye is making the image. The image actually exists. It is a point where all of these light rays are originating from. So we're going to call it a real image. And these are the big 3 things that you're going to be asked about when you're doing a ray diagram. You're going to be asked about whether or not the image is bigger or smaller, whether or not it's upside down or right side up, or if it's real or virtual. Alright, so we know that for an object beyond the center point, the image will be diminished, inverted, and real. But what about if the image is in between the center and the focal point? So let's say we have this image, this object sitting right here. And I always draw my objects above the line. That's kind of standard convention, and it makes drawing these easier. It's also easier to tell when something's inverted or not. Alright, so our first line, as always, travels parallel to this axis and then reflects through the focal point. Alright, our second line goes through the focal point just like before, And then it also reflects, but this time it reflects parallel to the axis. Again, the first two rays are kind of reverse of each other. And finally, our last line goes through the center of curvature from the object. Note, the line is actually originating from the object. It's just easiest to draw it from the center of curvature. Hits the mirror and then reflects straight back through the center of curvature, and voila, we have an image formed right here. So what would an observer see this time if they were looking at this image? So let's say you're sitting over here and you're looking at this whole setup. So you're going to see the object as being further from you than the image is. So the image actually looks closer, so it's bigger. The image is magnified as compared to the last time when it was diminished in size. So that's a difference from the last time. But just like the last time, it's inverted. So if we have our guy and the image of him is down here, this is his new head. He's inverted. And finally, it is again a real image because it's not formed behind the mirror, it's formed in front of the mirror. So again, these are the big three for an image that's formed by an object in between the center of curvature and the focal point. So what about if we put our image forming object in between the focal point and the mirror itself? So let's say we stick it right here. What's going to happen then? So this is kind of a special case, and the diagram looks a little different. But let's just start with what's familiar. Just like before, we're going to draw a line straight to the mirror and reflect it back through the focal point. So that's usual. That is totally normal. But now what are we going to do? We can't draw a line from here down through the focal point because the focal point's behind us. So we're going to just pretend like we're going through the focal point. I usually draw a dotted line just so that I can see better from the focal point to the object and then extend it to the mirror. So you have a light ray that looks like it's originating from the focal point. And this one is going to reflect parallel to the axis. And the same deal with the center of curvature. You can draw a dotted line just to help you see here. It'll hit this mirror and then reflect straight back across that dotted line and continue on into space. But what's happening? I mean, there's no place where these are going to meet each other, so where's the image formed? This is a sneaky image. It's being formed in a different way than the last two were. It's a virtual image. It's being formed behind the mirror. And you can find where it's being formed behind the mirror by extending the reflected lines backwards through the mirror until they meet. So I'm extending this line here, I'm extending this line right here, and I'm extending this line here. And you can see that they meet all nicely at a point. And this is where, to an observer, it would look like all of the light was coming from. So it forms a virtual image much in the same way as a flat mirror forms a virtual image. But what about the size? All right, this is where it kind of gets tricky. So if we have our guy standing here, and we're looking at his reflection, it's actually right here. But it looks like he's just gotten really tall. You can see he's kind of scaled up. So an image formed when the object is inside the focal point is actually going to be magnified. If you can see how he's gotten bigger compared to the original object. And it's going to be upright. He hasn't been reflected down here like he was in the last two examples. So an image formed from an object within the focal point is always going to be upright and magnified. And important to note, it is a virtual image. It's not some point out here where all of the light rays that are actually coming from. It's just a point behind the mirror, and I say behind, but it's not actually behind the mirror. It just looks like it's behind the mirror, where all of the light seems to be coming from, even though it's just reflecting off the mirror. So that's concave mirrors and ray diagrams for them. I hope this video was useful to you. Please comment and tell me what I need to fix or tell me what you thought about it. Thank you.